All right, welcome back. Okay, so today we're going to be talking about the rate of change with a line and its slope. So the rate of change is a way to look for a pattern between input values and output values. We have an independent value, which is known as the input or the x, and we have dependent variables that are the output or y. The rate of change is the dependent variables over the independent variables. So here's a series of x and y. If we were to plug it into an equation like last time, where when I plug in 3 for x, then I get 4 for y. When I plug in 6 for x, I get 8 for y. The question is there a constant rate of change here? Well, you'll notice that with the x variables that all of them are increasing by 3, and the y variables are all increasing by 4. So that is a constant rate of change and something that can be predicted. And so we get the rate of change, of 4/3. And since all these are constant, equal each other, then it is a constant rate of change. Would this be a constant rate of change? Well, what we notice is at the top we go plus 2, plus 2, plus 5, plus 2. And on the bottom we go plus 3, plus 3, plus 3. So when we set it up with the dependent variable, y, on top of the independent variable, x, we get these fractions. You'll notice not all of them equal each other. So the rates of change are variable and not constant. Let's look at this pattern. Plus 1 up top, plus 5 below. What would the fractions be? Remember, the dependent variable, which is y, goes on top of the independent variable, which is x. And so we get 5/1. They all equal each other, so the rates of change are constant. When we think about rates of change with straight lines, we think about their picture, or their slope. Here's an equation y equals x. When x equals 1, y equals 1. When x equals 2, y equals 2. When x equals 3, y equals 3. And we get the straight line. What would be the rate of change for this line, or its slope? Notice, when I go up 4, in order to get to the next point, I go to the right 4. Slope is known as rise over run, or the change in the y-coordinates over the change in the x-coordinates. So here we are back to this. So what would the slope be? Well, the rise was 4 and the run was 4. So it's 4/4 or 1. Think about that. That's a constant rate of change for the entire graph. Because if I was right here trying to get to the first dot, I would go up 4 and then I would go over 4. If I think about it simplifying down to 1/1, I've got a rate of change for every time I go up 1, I go over 1. Every time I go up 1, I go over 1. Every time I go up 1, I go over 1. See the pattern? When we do this, so many people have to think, hey, does it matter which way I count when I am finding out my rate of change or my slope? No, it doesn't. You just have to count accurately. Because what if I were to count this way? And then go up? Notice, I still get rise over run, 4/4, which still equals 1. You always get the same answer. What if you go down? Notice this would be -4 because when you go down the y-axis, that's the negative direction. Well, it can't be the same then. Sure, when I go to the left, do you notice that is also the negative direction? So I end up with -4/-4, which also equals 1. If I go this way, and then this way, once again, we still get the exact same answer. So to sum up, it doesn't matter which way you count, whichever way you would like. Just make sure that you count accurately. Because you're going to have a problem like this one. Let's see. If we count up, I go up 6, and I go over 3. Slope is easy and fun. Just remember, rise and over run. 6/3, which equals 2/1. Do you notice that when you take one big step of 6/3, That is the exact same thing as 3 little steps of 2 rise, 1 run, 2 rise, 1 run, 2 rise, 1 run. And so that's why we always say to make sure to simplify always. In this one, what would the slope be? All right, I'm back. Notice once again we're going to rise 2, and then I'm going to run 4. I get 2 over 4, which would simplify to 1/2, because that would get me rise 1, run 2, rise 1, run 2, rise 1, run 2, rise 1, run 2. What would this one be? All right, I'm back. Rise 1, and then run 4. Slope is easy and fun. Just remember rise over run, you get 1/4. What about this one? All right, I'm back. We run 2, and then when we go down, remember what happens when you go down? -4. Slope is easy and fun. Just remember, rise over run. Don't forget to simplify to -2. Here's an interesting one. What would the slope be of this? What's the rise? Well, there is no rise. There's only a run. So, since we're running 5, the rise was 0, the run was 5. What is the answer to 0 over 5? You got it, 0. The way I like to think about this one is, I have a person standing or skiing, and when you're skiing on a perfectly flat lake, you really don't go anywhere. You're just standing there. You go 0 miles an hour. What about this one? What's the rise? Well, the rise can be -4. What's the run? The run equals 0. Can you have 0 in the denominator? Never. And that's why this slope is called undefined. And I also like to think of it as a person was trying to ski. Instead of just standing there doing nothing, what would happen to a person that tried to ski this slope? They would fall. You cannot ski this slope. And so, there is no slope here. One thing you may have noticed is that positive slope always goes from low to high. Negative slopes goes from high to low. A 0 slope is a perfectly flat line, and an undefined slope, or no slope, is a perfectly vertical line. Okay? All right, everybody. That's it. We will talk to you guys tomorrow about how to, well, we'll talk to you guys tomorrow about this. If you got any questions, feel free to give me a call. Thanks.